Okay, let's look at this given polynomial f of x equals x squared over 2x squared plus 2x minus 4. Now our goal is going to be to graph this polynomial. So the first thing we have to do is factor the quadratic in the numerator. That's a difference of squares. This x squared minus 4 will factor into conjugates. And then also we need to factor out that denominator. I notice there is a GCF. So when I come over here, you can see I started by breaking down the difference of two squares, factoring out the GCF, and then continuing to factor down my quadratic. Now, when I see that a factor will cancel, I need to cancel it, but then also remember that canceling a factor will lead to a removable point of discontinuity, also known as a hole. So we'll get to that in a moment. But when you cancel a factor, it doesn't just go away. It leads to a point of discontinuity. So let's look at our simplified form because we're going to use it for the rest of our graphing and identifying important parts. We end up with x plus 1 over 2 times x plus 2. I'm going to leave it just like that as we continue on. Going back to that removable point of discontinuity, that canceled factor will tell us where the hole in our domain will be. It's going to be at x equals 1. I have to set it equal to 0 and solve. Then I take that value and I plug it into the simplified form of the polynomial. I plug 1 into the simplified form of the polynomial, so I get 1 plus 1 over 2 times 1 plus 2. All of that simplifies to 1/3. My input was a 1. The output, the f of x, was 1/3. This is going to lead to a hole on my graph. Continuing on with these points of discontinuity, there were two factors in my domain. Both of them lead to an undefined value in the domain of the function. We already dealt with this x minus 1 factor. Now let's look at x plus 2. Over here, I take the other factor, any remaining factors. In this case, it's x plus 2. Set it equal to 0, and we get a vertical asymptote at x equals -2. Next, we find our x and y intercept. Y-intercept is typically the easiest to find. All you got to do is plug 0 in for x, and I get an output of 1/4. That is my y-intercept. X is 0, y is 1/4. For the x-intercepts, you've got to remember this. You set the numerator equal to 0. You use the simplified numerator here. When I look at this simplified numerator, we get x plus 1, the other factor canceled. I set that numerator equal to 0, and I solve to get x equals -1, and I plot both of those on my graph. Lastly, we have to decide if we have a horizontal or slant asymptote, or maybe neither. To do this, we look at the powers of the polynomials in our function. If I go back to this given polynomial, the powers is the highest degree, x squared, x squared. Both of these polynomials are quadratic. They have the same degree, so the rule is that if the degree is equal, you look at the leading coefficients of the polynomial. So on these leading coefficients, in my numerator, the leading coefficient is a 1, even though I don't see it. The leading coefficient in my denominator is a 2, giving us the ratio of 1/2. So y equals 1/2 becomes our horizontal asymptote. I get all these important parts graphed, and then I have to add to it. So when I plot my intercepts, the hole, I notice I don't have anything on this quadrant of my graph. So I plug in some points. I picked -3 and -4. I plug them into the simplified form of the function, got their respective outputs. That gives me just a few more dots on my graph, and I'm able to plot the rational function. Now, just a reminder that your asymptotes guide the end behavior. So when I don't know which way my graph's supposed to go, know that your graph has to go towards these asymptotes. The arrows have to move towards the asymptotes. They guide the end behavior of our graph.